Hey, so that's the new intro. And we've changed our name as well. We've also bought some new cameras and recording equipment just to try and improve the sound quality over the last couple of videos. I know that's been a little bit of a talking point, so thanks for letting me know in the comments before. Please let me know if you think the quality's improved for the next videos, and particularly this video. And if there's anything that I can do to make the content better, then just let me know and we'll see what we can do to make it work. So anyway, back to the engine. In this episode, we're going to pull the crankshaft out of the block, but first we need to take some measurements. There'll be some critical measurements that we need to know if we're going to determine that we're going to reuse this crankshaft for the build, being that we're going for 1,000 horsepower. We were told that this engine had 230,000 kilometers on it prior to it becoming part of somebody's compost heap in his shed. So enough of that, let's crack on. We will just check the end float and the crank. Now, the thrust bearing, if you're familiar with the small block stuff, the small block Chevys, you've got a thrust bearing at number 5 position. So counting from your front, you've got 1, 2, 3, 4, 5 main caps. With the LS motors, your thrust bearing is in number 3. So you'll see the design of the thrust bearing when we've got the cap off. But for now, we're just going to check the end float. To check the end float, you want to have a dial indicator set up on the end of the crank, and just taking a screwdriver and going in between your main cap and your counterweight, you'll hear that. Okay, so what we'll do, the best way to do this is to send the crank all the way forwards. So just a little lever there, all the way forwards, and then we'll zero our dial indicator. The allowable end float for the LS1 is 7 thou, which is 0.18 of a millimeter. So now that we're at 0 on our dial indicator, we'll just bump the crankshaft back towards the back of the block. Right, that's to the back. That's back to the front. So we're about 0.14. One other thing to note, I guess, here is while this one's coming up in specification, if it didn't come up in specification, it's most likely going to be the thrust bearing that you'll see inside this cap when we get the cap off. Potentially it wouldn't be, most likely that it is, but I actually have done a small block Chev not too long ago, and the thrust collar on the crank had gone, it was worn so badly that the crankshaft had to be replaced. So yeah, it is a worthwhile check, just getting that measurement and checking back to your specs and making sure that it's in tolerance. So the reluctor wheel that's being read by the crank angle sensor, it's got its own run-out tolerance, and that run-out tolerance is 0.25 of a millimeter. Essentially, the crank angle sensor would struggle to read it if it was any worse than that. Obviously, that's amplified if you do have excessive thrust in your crankshaft, which we don't here. So expecting this one to be okay, but expecting isn't good enough. We've got to turn this over and just have a check. If you have got a dirty old engine like this was, then it's best to get any of that debris out, because as you turn the engine over, your rings are just going to start scoring that through your bores. Keep your thrust all applied one way. We're on 0. And what we're doing is just going to make a note of the lowest point, and then we'll reset that to 0. It looks like it's going to be here. Okay, so that's re-zeroed now. I don't know how well you can see the numbers on the camera, but the blue numbers, the large increments, that's 0.1 of a millimeter. So while we're set at the low point, I've just made a mark on that counterweight there. So we'll just turn it over and just keeping a small amount of weight on the crank, making sure it's push towards the back of the engine and we rotate. Two. Remember the tolerance is 0.25 of a millimetre and we're just at 0.2 now. And just to make sure we've got that repeatability, we should come back to our 0 mark now. There we go. Okay, so just shy of 0.2, so we're in spec. Okay, so now we're going to crack off. Well, you can see number 1 is off. We're going to crack off these big end caps and take our pistons out. So I'll set the camera up so you see exactly how I do that. But one thing I will say now, so this is the first one that's out, cylinder 1. One thing that you really want to do is mark them up, make sure that you know that that is piston number 1 for identification purposes later. Also for some diagnostics, I mean we can see in this one that this bearing's got some wear, so that tells us to go and have a look at our crank and make sure our crank is actually usable. So yeah, keep everything together. The big end caps, they only go on one way. It's pretty obvious which way they go, but if you put them on the wrong way, you can do some damage. So make sure that that goes back together. Keep your bearings in the right halves so that you can identify that stuff later too. And your bolts back where your bolts came from. Really important that these will all be lined up 1, 2, 3, 4, 5, 6, 7, 8 on the bench. But I'll set up now and you can see how I do that. You just rotate your crank until your big end journals sort of almost at bottom dead center, but you can still get to your big end bolts, your big end cap bolts. So cracking. And again, if you're used to the small box shed stuff, you're used to this being a the bolts in from the other way. So here you're just taking the nuts off. One of the changes with the LS engine, they did away with that. So now you actually just take a bolt out as opposed to taking the nut off a stud. Now GM do make some special tools here again. So once you've got your main cap or your big end cap off, you can screw in 2 long aluminium sort of dummy bolts, and you can use those to tap with a mallet to press out. I haven't got those. You can use anything that you want that screws into those holes if you've got to pick up the right thread. But what I'll do here, let's move the camera back so you can see. I also like to get my knee under there to be able to position to catch the piston as it comes out. But just 2 thumbs on, and just very carefully as you're pushing the con rod and the piston down out through the cylinder, just making sure that that cap isn't fouling up on the journal or going to scratch that journal. It does come nice and easy because we've got a nice clean engine, so that one's perfectly fine to just push straight out and then just catch with the knee. Just stuck at the top there. So what I'll do, just using the handle of the soft hammer. I can feel that's popped. And then same again with your big end. Just make sure that you're not dragging that through your cylinder bores and creating unnecessary damage. So although this sucks for me, it's actually quite a good example to catch on camera. I did want to reuse this crank, but as I've got that second cylinder number 2 piston out, and you can see the contrast between cylinder number 2 journal and cylinder number 1. There's actually, I don't know how well the camera will pick that up, but there's a good step in there. I mean, you saw those bearings, the bearings that had it, and our crank journal's worn, and that feels like it's Yeah, we'll get some measurements after and see if that's something that can be ground and reused, but I suspect we're probably looking at a new crank now. Just wanted to capture that and show you the difference. You can also see how sort of freshly polished this is still, even after such a 230,000 kilometers. Whereas this, you can see all those lines and scores in it. So yeah, oh well, we move on. Now we're into taking the main caps off. So again, not that it really matters, but I'm going to start from the outside in. So I'll do 1, then 5, then 2, then 4, and finally 3, the thrust, and then we'll have a look at that thrust bearing when it comes out. So all you need to do, you're just backing off these, but what you do have in addition to the old small block stuff is you've got the cross bolt, which builds a lot of strength into this LS design. So what you will see when we take this bolt out, there's actually a seal behind there, because you've got oil splashing around in here obviously. So that's another thing to make sure that you replace when you put these things back together and you're ordering your gasket kits. It will come with one anyway, but it's one that can be missed if you're not thinking. So yeah, 6 bolts each cap, starting from the outside, working our way in. That's the seal, the back end of the bolt. Obviously needs replacing. With the bolts out, and you can see they're all out. The cross bolts are out. GM actually do have a special tool for here where we actually use a slide hammer to knock this up. But if you haven't got that, then you can see these holes here. They provide a really good spot to just get something in there and knock the cap upwards. Now there with the screwdrivers, it's not exactly best practice getting them in here. But if you can tell your cap's loose and you're literally just lifting it up off the cap, off your bearing, that's okay. But you wouldn't want to pry in here because that's another critical mating surface. Right, even though we do suspect that this crankshaft's garbage, we'll still take care of it when we pull it out. I'll still show you how to do that. So we've got a couple of V-blocks set up on the bench there. I'll show you those in a sec. Once your main caps are out, it's just a case of picking the crank out and resting it on those V-blocks. And the purpose of the V-blocks is just to make sure you don't rest it on that reluctor wheel. That's the crank out, sitting on the V-blocks. So my V-blocks are a steel V-block, so I've just got some rags protecting those journals. And this is the difference between your thrust bearing and your normal main bearing. So the thrust bearing still takes load like the radial bearing with the forces of the crankshaft acting down on the journal, but then it also takes side load both on this side and this side. So same sort of things, just a soft metal. These are little oil grooves to let oil in and act on that surface, and that's just on your number 3 main cap, as opposed to this is 1, 2, 4 and 5. And then coming out from your thrust bearing, or where your thrust bearing sits, being when you're looking at your crank, you got 1, 2, 3, number 3, So here and here are your thrust surfaces on your crank. The other thing that's notable about this crankshaft and the LS1 is you see these holes. They've been rifled or gun drilled, depends what you want to call them. That lightens the weight of the crank, so that goes right through. You can see my finger coming through there, so right through all your mains. What it does is it lightens the crank itself, but it doesn't actually affect any of the inertia because all the weight and your counterweights is obviously on the outside of that. So that's a pretty cool feature with the LS1 crank. And that's all for now. So in the next episode, we'll look at stripping and cleaning all our parts ready for the build. So hope you enjoyed this video and look forward to seeing you in the next episode. Thanks. Bye for now.